We're going to look at this particular equation, which is used often in physics. It has to do with free fall of an object. So here, S represents distance, the distance in which an object is falling, and G is the gravitational pull of the Earth, and T is time. So if I'm on top of a building, let's say, I'm standing up here, and I want to drop something, not throw it, but just drop it. So let's say I have some sort of ball, and I want to drop it a certain height. And in this case, our height is represented by S for distance. And I want to find out how long will it take for that ball to hit the ground. Then I would use this particular equation, because I know how tall the building is, and I know the gravitational constant. So I just want to figure out how much time it takes. So I want to solve for t. So I want to isolate what it is I'm solving for. So one technique that might help is to take a highlighter and highlight t. So there are a couple things happening to t. It's being squared, it's being multiplied by g, or you could look at this as g divided by 2, depending on how you look at it. So let's just take it bit by bit. So the first thing I want to do is I want to get rid of that fraction. No one likes a fraction. So let's get rid of that fraction. So I have 1/2 g t squared. So let's turn that 1/2 into a 2. So what would I do to turn the 1/2 into a 2? I would have to multiply it by its inverse. So the inverse of 1/2 is 2. So where is that 2? That 2 is in the numerator. I very intentionally put it up there. We could write 2, or we could write 2 over 1. It really doesn't matter. It's the same thing. So remember, there's no addition or subtraction going on here. This is one term, so I'm just doubling that one term. So what I do to one side of the equation, I have to do to the other to keep it balanced. So if I double the right side of my equation, I have to double everything on the left side of my equation. Fortunately, I only have one thing there to double. So what happens here? Well, this whole thing becomes 1, because 2 over 1 times 1/2, that's the inverse property of multiplication. So that all divides out to 1. So then I'm left with 2s is equal to gt squared. Well, immediately that looks better, doesn't it? Okay, so if you just remember that numbers are numbers, they look funny. Okay, I don't know what you think, but I think 2 is a pretty funny looking number. 8 is a pretty funny looking number. They're all funny looking numbers. G just happens to be another funny looking number. So what am I going to do to G to make it turn into 1? Well, let's think about that. If I have 3 and I want to make it turn into 1, what am I going to do to that? Well, I'm going to divide it by 3. And that would give me 1. How about if I had, I don't know, 15? What would I do to 15 to make it turn into 1? I would have to divide it by itself, and that turns into 1. So the question is, if I have G, what am I going to do to G? G is just another number, just like 15, just like 3. If I want to turn that into 1, I would just divide it by itself. So that gives me 1. So that means if I want G to turn into a 1, because it's multiplying to T, that means I will divide both sides of my equation, all terms, by G. So what does that leave me? Well, there's nothing here that can simplify. So that's 2s divided by G is equal to, Well, what happens here? We have g divided by g. We did that on purpose because we wanted that to become a 1. So we're left with t squared. So I'm close. I want to solve for t, but I have t squared. So I need to think about inverse operations. So let's take a moment to talk about inverse operations. First of all, what do I mean by operations? So you may have heard of the order of operations. So what are operations? Well, if we think of operations, we think of things like adding, subtracting, multiplying, dividing. And then we have this thing called exponents, which I'm going to write some number raised to a, I'm going to use p for power, right? So these are inverse operations because they undo each other. So they're operations that undo each other. So I'm going to put here inverse operations undo each other. That's important to remember. But I'm stuck. What is the inverse operation of raising something to a power? So in this particular case, if I'm looking for the inverse, let's just make up something. Let's say I'm making up the inverse of, let's do something like 4 squared. So we know 4 squared is the same as 4 times 4, which gives us 16. So the question is, how do I get from 16 back to the original base? The original base was 4. So how do I get from 16 to 4? Well, you could tell me you're going to divide by 4, but how would I know to do that? What operation makes it go from 16 to 4? Or what operation makes it go from 9 to 3? Or what operation makes it go from 25 to 5? So you may have already come up with the answer. So if I take the square root of 16, I get 4. Take the square root of 9, I get 3. If I take the square root of 25, I get 5. So what undoes a square? Well, if I have 4 squared, if I square root 4 squared, remember, 4 squared is the same as 4 times 4, which is 16. So 4 squared is the same as 16. So the square root of 16 is 4. So what must the square root of 4 squared be? Square root of 4 squared is 4. So what I want you to realize is the square root undoes the square. So the inverse operation would be the, in this case, p root of whatever the number is. Okay? So a root undoes a square, as I've shown you right here. So this is squared. So how do I get rid of a square? I showed you here. You have to take the square root. So I'm going to take the square root. And remember, I have to keep my equation balanced, right? So we talk about balancing. I multiplied everything on the right by 2, so I had to multiply everything on the left by 2. I divided everything on the right by g. I have to divide everything on the left by g. So if I take the square root of everything on the right, I have to take the square root of everything on the left. I have to do everything. So then that means I have 2s divided by g. And I want you to note that I'm taking that square root and I'm putting this whole thing underneath the square root sign. And that equals t, because the square root undoes a square. So that's what we call inverse operations. These are inverse operations. They undo each other. They're opposites. Opposite operations. So I've just solved for t. If you're just being very systematic and you do the inverse property of addition, inverse property of multiplication, and you use your inverse operations, you're able to undo any crazy problem that is given to you.